All right, seventh graders. So just a quick recap. Remember how Wegener, his idea was not believed by the scientific community because it was pretty wacky. The concept of the ground moving seemed really far-fetched. And he could not in his lifetime come up with an explanation of how the continents could actually move. Well, it wasn't until about 2 decades later when he first comes up with his idea that we found an answer. And the secret was hiding on the ocean floor the entire time of how the continents move. Now, for the longest time, scientists used to think that the ocean floor was flat and sandy, like the picture you see here. But we realized that we were wrong. We came to realize with the help of sonar, which I'll talk about more in a minute, that our ocean floor really, I'm going to change this, that our ocean floor really, it has highs and lows and valleys and mountains, and we now have bathymetric maps, which are maps of our ocean floor. These might look a lot like topographic maps to you if you've ever seen those, where these lines show elevation. But here, the lines show how deep something goes. So bath referring to water, and bathymetric map then shows elevations up and down underneath the water. So you can have a bathymetric map of the ocean, of Lake Calhoun, of a river, any body of water. And the way that scientists finally figured out what the bottom of the ocean looks like is with the use of sonar. And so sonar stands for sound navigation and ranging. And some of you may have used sonar before on a fishing boat that you may be on, where it'll send sound waves down to the bottom of the lake and they'll bounce back up. And depending on how much time it takes to go down and back, we can determine how deep the water is. We can also use sonar to try to look for fish and other things where we can't see them. So I'm going to play for you a quick video. Actually, it's not really a video. It is more like an online interactive about sonar. And so just to give you a sense of what sonar looks like, we can, let's see here, sorry. So the boat would go across and send the sound waves down, bounce back to the boat, and has a receiver. And again, deeper the water, the more time it takes for the sound to go down and back. There's all different kinds of sonar where it can determine, mountain ranges and valleys as well. Here's another kind where it just takes a much wider path called a multi-beam sonar scanner. There's this kind which has a device way in the back of the boat. And finally, this really cool type of sonar actually allows scientists to determine the rock type and the density of the rock even below the surface. So anyway, sonar, basic, sound goes down, comes back, longer it takes, the deeper it is. So this technology was finally developed in the 1950s. And so with that, scientists started mapping the ocean floor. Oops, sorry. And what they noticed, it's kind of similar to this, is that the ocean floor is not flat, that there are deep, deep valleys and crevices, and then there's high peaks and mountains. And by mapping the ocean floor, scientists found the clue to how the continents are moving. Now that is going to be for next lesson, but today's lesson really is all about sonar. So what I need you to do right now with your table group is work on the stop and think questions in your packet on page 7. And there's actually 4 questions there, letters A through D. So if you can work on those, and then you will be going over those answers with the sub. Okay. Or with me, actually. I forgot I have them up here, so we're going to go over those together. So once you've had a chance to work on them, then you're going to go over the answers. So if the sub could stop and pause, here is answer number 1, since I gave that away, but it is also in the reading on the previous page. So I guess you should go back to page 6, read page 6 as a class, and then get started on your stop and think questions. Sorry for the confusion. All right. Welcome back. Here's the answer for, here's the answer for number 2. Just got to take that number of 1,500 meters and times it by how many seconds. Okay, pretty simple. I'm gonna move this all around. Okay, next one. What's the relationship of the depth of the water to the total distance the sound wave travels? Basically, as depth changes, how does it affect the distance of the sound wave? So obviously, the deeper you go, the more time it's going to take for the wave to go down, or the sound wave to go down and back up to the top. So the distance or the depth of how deep down that ocean floor is, or the bottom of a lake, is half the distance the sound wave had to travel, because the sound wave goes down and back. And then finally, when you find out how far a sound wave has traveled, how can you tell how deep the water is? Well, this is much like the question before. All you got to do is, once you know how far the sound wave has traveled, just divide the distance by 2. Very basic. Okay, so now that we have completed page 7 together, you can stop this lovely screencast. And then there is one more screencast to watch where you will see me showing you how to do the lab today. Thank you.